Concentrations of solutions. This is a numerical way of determining concentrations. One way of determining concentration is molarity. And molarity was given the symbol big M, and it stands for moles of solute over liters of solution. And we'll work some problems using these eventually, but that's one way of expressing concentration. Another method of expressing concentration is molality. It is given a symbol little m. It is moles of solute over kilograms, this is the oddball one, solvent. A third way to express concentration is known as mole fraction. And this one here is going to look a little bit different too. It's the moles of some compound A all over A, moles of A plus moles of B. I guess I should use N. Let me use N, because N is what we use for moles, correct? N of A all over moles of A plus moles of B plus moles of C, whatever's in the solution. So that is mole fraction. Another way of expressing concentration, 4 is mass per volume. Earlier we called that density, but for this class, mass is usually in grams, volume is in milliliters. And it's usually a mass percent times 100, mass volume percent. And it is grams of solute per milliliter of solution times 100, and normally it's grams per mass per milliliter percent. That's how it's going to, it's a percent mass by volume. Or they will say percent mass volume. We can have percent by mass. So that's going to be grams of solute over grams of solution times 100. What's cool about this one here, that is grams of solute plus grams of solution or solvent will equal grams of solution. Number 6, we can have percent by volume, which means we have volume of solute divided by volume of solution times 100. This is worth noting. Milliliters of solute plus milliliters of solvent will not equal milliliters of solution because of those intermolecular forces. So if I had, I'll just draw it up here, if I had 10 milliliters of water and I have 10 milliliters of alcohol, when I put them together, I will get roughly 18 to 19 milliliters, because these intermolecular forces are going to get attracted to each other. So this is worth noting on the volume of solutions, that those do not work out. Number 7 then is parts per million. Parts per million is expressed in milligrams per liter. And it does not have to be times 100. And quite often water testing runs it in milligrams per liter. Another one that you may run into if you take more chemistry, like analytical chemistry, it's worth noting, is normality. And it's given a symbol N. And it is known as equivalence of solute over liters solution. So I'm going to have some other videos that are going to show you calculations for these, at least 5 or 6 of these, so you get to see how to do calculations of concentrations.